All right, everyone, what's up? Mr. D'Souza here. We're going to do the practice problems for lesson 3, which is about inscribed angles. This is a longer homework, but mainly it's because it kind of compiles everything that you learned from lesson 1, 2, and 3. And you should kind of have a bigger feeling of it's a little bit more difficult, mainly because these are the things that you're kind of going to see on the test. You see how like everything's kind of coming together. So feel free to skip around. But the point of this video is to kind of go over all the questions so that when you submit your practice problems, everything should be perfect. All right, so that being said, give me 1 second. Perfect. So what we're going to do is we're going to do the first question together. Use the diagram below to answer questions A through C. Let me pick my colors. Let's do an orange, because why not? Okay, what is the name of the circle? So remember, names of circles are the center of the circle, and the center of this circle is D. So this is called circle D. Name one inscribed angle. We learned that inscribed angles are angles whose vertex is on the circle. And what we mean by on the circle is the circumference. So the circumference of the circle is, the circle itself. The only angle whose vertex is on the circumference is BAC, or CAB, either one. So angle BAC. And remember, the vertex of an angle is always the middle letter. All right, next. If the measure of arc BC is 64 degrees, so just to highlight, boom, this is arc BC. If that is 64 degrees, what's the measure of BDC? So BDC, I'll highlight it in blue, B to D to C. We want to know what the measure of that angle is. Now we got to ask ourselves, okay, we're in circles. What type of angles do we know? Hi, Riley. We know about central angles. We know about inscribed angles, okay? Angle BDC is a central angle because the vertex of the angle is the center of the circle. So we know that the property of central angles is the central angle is equal to the measure of its intercepted arc. So the intercepted arc is BC. Therefore, the measure of this angle is D. My cat is going crazy, just like always. The cat is so nosy. So if the arc is 64, the angle is 64 degrees. 64. Okay. If the measure of arc BC is 64, so we're keeping to that. Now I want to know the measure of BAC. Well, we said BAC is an inscribed angle. And what we learned is that inscribed angles are half the measure of the intercepted arc. So if the intercepted arc is 64, half of 64 is 32. Okay, moving on. All right. In the diagram below, circle M shown, the measure of PRQ is 308 degrees. Which of the following is the measure of PRQ? Sorry, the measure of angle PRQ. So arc PRQ is the following. I'm going to outline it, as we should always mark up our diagram. So P to R to Q. So the yellow region is 308 degrees. And we want to know, again, I'm going to outline it for us, PRQ. So PRQ. So I want to know this angle eventually. The only thing that's given to us is the yellow major arc. My cat's trying to get up here. All right, so the major arc is 308 degrees. So if I want to find this remaining piece that is over here, let me just hide this. If I want to find this piece, well, we know a whole circle is 360 degrees. So if I subtract 308 degrees, I'm left with the blue region. So I'm going to do 360 minus 308, and we get 52 degrees. So this is going to be 52 degrees. Okay. So the next thing that we want to do is, how does that help us? All right, I am back. I had to take care of my cat. All right, so anywho's, so now we got the blue region. The blue region says, hey, this intercepted arc is 52 degrees. Well, remember, we want to find the measure of PRQ. PRQ is an inscribed angle. PRQ is an inscribed angle. So the angle is half the measure of the intercepted arc. So half of 52 is 26. So it's 26 degrees. All right, so the next thing we're gonna do, my cat's insane. He only gets insane when I do these videos. All day, he's just chill, usually up on that little perch. Then when I make these videos, he just goes nuts underneath my table. Anywho, let's continue. In circle D, the measure of angle CAB is 32 degrees. Which of the following is the measure of AC? So we want the measure of AC. The measure of AC is here. Okay. Then what they give us is angle CAB. So angle CAB is this angle right here. So we got to follow our nose. If they only give us that angle, let's see what we can do with that angle. So if angle 32 is an inscribed angle, we know that its intercepted arc is going to be double the angle. So double of 32 is 64. So this green arc is 64 degrees. But this is where we got to be careful. Check this out. What is the measure of this yellow arc? If you're saying 180 degrees, you're right. Check this out. AB is a diameter. So that means it cut the circle in half. So this whole arc is 180. So if I subtract the green piece, right, which was 64, so 180 minus 64, that should give me the remaining blue piece, which is 116 degrees. Okay, next. All right, ooh, whoa, just skipped a whole bunch. Cool. So in circle K, the measure of NPL, so NPL, that's this whole region, is twice the measure of NL. So NL is going to be this. So NL, remember, minor arc, it's going to be this. Okay, so which of the following is angle NML? So they actually want you to set up a equation. And we're back again. Oh, Riley. All right, so they actually want us to set up some kind of equation. So it's telling us that NPL is twice the measure of NL. But we don't know what arc NL is. So we're going to say that NL, that arc, is X. We don't know. But didn't we say NPL is twice of that? So twice of X is 2X. Whoops. So this black piece is X, and this yellow piece is 2X, because it's twice the black piece. Now, let's try to make an equation. What do you know about if we add up all the arcs in a circle, or like the full measure of a circle? 360 degrees, right? So we know that X plus 2X is 360 degrees. 3X is 360. Divide by 3, divide by 3, and we get that X is 120 degrees. But X was arc NL, so NL, okay? But we wanted to know angle NML, so NML, okay? So if we do 360 minus 120, so I'm gonna just change colors. Whoops, did I mess that up? So if we do 360 minus 120, 360 minus 120 is 240. So now we know that this yellow piece is 240 degrees, and NML is an inscribed angle, so half of 240 is 120. Therefore, this angle, which is half of this arc, 240, is 120. So next, this one actually requires you to think back to the last practice problems. Okay, so long as if you did those practice problems, you're probably going to be really good with this question. Okay, in other words, I hope you watched the video. It takes forever to make these, especially when you have a cat. Kidding, but not really. Okay, in the diagram shown in the circle A, segments UV and UT are congruent. So UV and UT are congruent. If the measure of VST is 120, so VST, if this arc is 220 degrees, determine the measure of angle VSU. So VSU is this one. We want to know what this is. Show how you arrived at your answer. All right, so check this out. Let's follow our nose. They only give us one number to work with, so we got to do something with that number. I marked up my diagram. I'm ready to go. So that blue piece is 220. I could figure out the remaining piece, so that's arc VUT, by subtracting that from 360, right? If a full circle is 360, I subtract 220, or in other words, I subtract that blue piece away, I get the yellow piece. So we're going to do 360 minus 220, and we get 140. So this yellow piece is 140 degrees. Now think back to the last set of practice problems. I believe it was the last question that you learned that congruent chords intersect congruent arcs. So do you see how this chord intersects this arc? And do you see that this chord, who's congruent to the other chord that I just marked up, intersects this arc? Well, by the property that you learned in the last practice problems, if the chords are congruent, then the arcs are going to be congruent. So that means UT is congruent to UV. But if the whole thing is 140, then that means each piece is 70, because you got to divide it by 2. So 140 divided by 2 is 70. So this is 70 degrees. Therefore, this is 70 degrees. But wait, we're there. We're done. Because if we want to find this angle, so USV or VSU, is an inscribed angle. The vertex is on the circumference of the circle. The angle of an inscribed angle is half the measure of its intercepted arc. So what's half of 70? I know the answer, but you know what? Use your calculator. 70 divided by 30. Oh, 70 divided by 2. That's so funny. It's very late. You have no idea. Is 35. So angle, the measure of angle VSU is 35 degrees. If you do not write it this way, you get points taken off because you have to answer it the way that they asked you. Measure of VSU. Okay, this is a very common looking type of problem you'd see on the regions. Moving on. All right, this problem's crazy, mainly because there's so many ways you can do this. I was working on this problem with Miss James, and we both did it completely separate ways. So if you find that I did this a different way than what you did, that's okay. So long as if you get the same answer, and you're using the correct mathematical properties that we've been learning about circles, you're good. All right. So they tell you the following. In circle N, triangle ABC has been inscribed. When something's inscribed, think about it. An inscribed angle is when all those vertices, all those points that make the angle are on the circle. So see triangle ABC, the vertices of that triangle are on the circle. Okay? It is known that AB is congruent to AC. Okay. Now I'm going to foreshadow a little bit. AB and AC are chords. And if you remember, chords that are congruent, because remember it's isosceles, intersect. congruent arcs. So arc BA is congruent to arc AC, but we'll get there. Just plant that seed in your head. Okay. It also tells us that DC is perpendicular to AB, which means that it creates a right angle. Boom, that's already written there. And last but not least, let's see if I can fit all this stuff in here. Because I know it's gonna be a lot of writing. The measure of DCB is 23 degrees. So DCB, this angle right over here, this is 23 degrees. Okay. Now we need to find two things. Hi, Riley. We need to find the measure of BDC. So BDC, I'll outline in green because, as you know, that is the best color. So BDC. BDC, I want this angle. We'll focus on that first, and we'll get there. So what I always told my students is sometimes when you get a crazy looking picture with numbers and all these properties, follow your nose. Think about it. They only gave you two numbers. More obviously, they gave us the number 23. We can talk about how that's an inscribed angle. We can talk about how that's an angle in a triangle. We're going to get to all that. But also they give us a 90-degree angle. Now, if you notice, this 90-degree angle is nothing really special yet because it's not an inscribed angle. It's not a central angle. But you're going to see where it's going to come up soon. So you might want to ask yourself, what information do I know? So I know that DCB, the angle that makes 23 degrees, is an inscribed angle because the vertex right over here is on the circle. That means the intercepted arc, DB, is going to be double the angle. Because remember, the angle is double the intercepted arc. So to get the arc, it's the opposite. You're going to double. So arc DB is 14.6 degrees. Now you might be asking yourself, Mr. D'Souza, that didn't help us, right? We're trying to find this angle. Don't you worry. We're going to get there. Okay. So something else you can say is, oh, but Mr. D'Souza, this is what I noticed. I noticed that we can use the triangle sum theorem. You might be saying, what? Check this out. If I outline this triangle, we know two angles and we're missing one. We know 90 and 23. And with that information, I can find the last angle. So by the triangle sum theorem, if I add up the angles and subtract that answer from 180, we're going to get this angle B, or angle ABC. So with that being said, I'm going to do 90 plus 23 is 113. 180 minus 113 is 67. So this angle here is 67 degrees. Okay, but wait. Aren't those two sides congruent? Remember the yellow sides that we outlined? So if two sides of a triangle are congruent, what type of triangle is it? Yeah, it's an isosceles triangle. And what else do we know about isosceles triangle? Yeah, you're right. So the angles that are opposite those congruent sides are congruent. So the opposite angle of AC is this one, which is 67. But the opposite angle of AB is this whole angle. So this whole angle, ACB, is 67 degrees. And I'm going to be very obvious. I'm going to outline the angle in purple so we don't get confused, right? 67 goes with this purple angle, which means, couldn't we get this angle now? Triangle sum theorem. Let me redraw this picture. It's a little bit small, but let's see if I can do this. So that's A, that's C, that's B. We don't know what A is. C is 67, and B is 67. So I'm going to do 67 plus 67. That's 134. 180 minus 134 is 46. So angle A is 46 degrees. Now, I want you to look at something. I want you to check this out. I'm going to outline this angle. And again, you might not have seen this. There's just many other ways you could do this, but you might not have seen it. Check this out. Angle A is this angle. And that angle intersects this arc. Right? Okay, so check this out. Check this out. So if it's an inscribed angle, the angle is half the measure of the arc. So if we're going in the opposite direction, we're going to multiply by 2. So 46 times 2 is 92. So this angle is 92. Whoops, I have it in a weird format. So we got 92. But check this out. Let's use pink. Let's make it crazy obvious. This angle, the angle that we're originally looking for, also intersects that arc. So if this is 92, what must this angle be? If it's an inscribed angle, you have it, right? So 92 divided by 2 is 46. Actually, we talked about this in the lesson. If two angles in a circle intercept the same arc, the angles must be equal. So the measure of angle BDC is 46 degrees. Okay? All right. Last part. We want DAC. DAC. So DAC is the following. My cat is playing with my computer charger. That's awesome. DAC. DAC. All right. If you comment, so you know when we post this, you can leave like a private comment. If you leave a private comment, typing the name of my cat, I'll give you a couple extra points when you submit your work for your class participation. Okay, so now we want DAC. Now check this out. I don't want to erase everything. I know it's going to get a little crazy, but I think it's going to be really helpful. Let's use orange because we haven't used that yet. All right. Oh, I don't want to use a highlighter though. My cat's about to knock over a whole bunch of stuff. There it goes. 1 second. All right, so I changed my mind. Count how many times I had to stop to get him to go up there. That will give you the extra credit. I changed my mind. How many times did I have to stop to get my cat out of my table up there? All right. Anywho, let's do this. We're almost done. So check this out. This is an inscribed angle. Okay? If you remember, if you remember, check this out. This angle that I'm highlighting here was 23 degrees, but we know the whole thing is 67, right? Remember the whole angle is 67? So if I want to find this piece over here, so I'm going to highlight it with 2 arcs. We're going to do 67 minus 23, and we get 44. So this orange angle is going to be 44. Whoops. It's getting a little messy. Let's see. So this angle is 44 degrees, right? Because 44 plus 23 is the whole angle. That's 67. But this is an inscribed angle. So this piece, right, is double that. So double of 44 is 88. And what if I told you we're basically done? And I'm going to erase everything except for what we have. So you might be like, Mr. Sousa, how do we know that? How do we know that? I got you. Don't worry. All right. So we got that. Let me make this a little thicker so we can actually see the lines. All right. DA is 88. We also got that DB is 46. Remember how I said, oh, in the very beginning, these two lines are congruent. They're chords. So the arcs that they intersect are going to be congruent too. So B to A is 88 plus 46. 88 plus 46 is 134. So the measure, let's use a different color. The measure of arc AB, what did I say? It's 134. But isn't that the same arc as AC, right? Because this yellow congruent chord is the same as AB. So that also means that the measure of arc AC is 134 degrees. That means this piece is 134. But we want to know DAC, so D to A to C. So in other words, it wants us to add the blue piece plus the orange piece, and this should equal the measure of arc DAC. Well, we know the orange piece is 88, and we know that the blue piece is 134. So when we add 88 and 134, that's 222 degrees. So our final answer is the measure of DAC, that arc, is equal to 222 degrees. I'm going to be honest, this was a very intense question. There are so many ways you could have done this. You didn't even have to use the congruent chords. Congruent chords intersect congruent arcs. You didn't even have to use that. I believe Ms. James just used a whole bunch of inscribed angles and found all of the pieces. You could have done a lot of different things with this. But again, if you got 222 for part B, awesome job. All right, the last thing is actually the next lesson. So I'm going to go super fast with this. If you got it, good. If not, this is part 1 of Thursday's lesson. So check this out. Again, we're going to use green, darker green, the best color in the world. Okay, so it tells us that the chords A, B, and C, D are parallel. That's awesome. Well, what information does that tell you? Well, parallel lines cut by a transversal. Remember, if you can trace a Z, that's like a very quick way to see angles that are congruent. So we know angle 1 and angle 2 are congruent. So angle 1 is congruent to angle 2. The mathematical term for that is alternate interior angles. Given that, what can you say about AC and BD, those arcs? Well, I'm going to tell you what you can say about those things. All right, so let's pretend that this is 30 degrees. Let's pretend that angle B, just for an example, it could be anything, but let's pretend it was 30. What's the measure of arc AC? Well, it's double of 30 because the angle is half the measure of the arc, so going the opposite way. Double of 30 is 60. But these two angles should be the same, right? Because they're alternate interior, so this also has to be 30. Therefore, what do we know about arc BD? It's also 60 degrees. So now what do we know about the arc AC and BD? They're congruent, okay? The same logic applies, right? Remember I said congruent angles intersect congruent arcs in circles. Again, congruent angles intercept congruent arcs. What we can say now, and again, I know this is super fast, but that's the point, because Thursday, tomorrow, you're going to get a full lesson on this. Parallel chords. Oh, you can't see it because my face is in the way. Whoop. Parallel chords will intercept congruent arcs. I hope this was helpful. I tried to do it a little bit faster so that it wasn't such a long video. I hope. We'll see. Yeah, leave comments. Let me know how I can make this better for all of you. And please, if you need more help, come to office hours from 10 to 11, day except for Friday for distance learning. All right. I hope all of you have a great rest of your day, and I will talk to you all later. See you later, guys and girls.